Good day girls and welcome to the class. Hope all of you are fine. We thank God for this day and all the blessings we receive from God. Today we shall study Science 1, Chapter 10, Space Missions. In this chapter we shall study about space missions, classification of artificial satellites, satellite launch vehicles, artificial satellites, orbits of artificial satellites, space missions away from the Earth. Man has always been curious about unknown places, and he has always been eager to expand the horizons of his knowledge by exploring the unknown world. He must have had deep curiosity about the space and the many twinkling stars in the dark sky. He must have had dreams to fly to the space and must have been working for that. Space missions. Substantial developments in technology, especially space technology, in the later half of 20th century resulted in the development of spacecrafts making space voyages possible. Since then, more than 1,000 artificial satellites have been placed into orbits around the Earth. Additionally, space missions have been undertaken for close observation of various objects in our solar system. We can classify the space missions into two categories. The objectives of space missions based on these categories are: the first objective is to put the artificial satellites in orbits around the Earth for research and various other useful applications. Second, to send the spacecrafts to outer space for close observations and understanding of the objects in solar system or even outside the solar system. Need and importance of space missions. The world has become a global village due to space missions. We can contact a person in any part of the world within a second. We can gather information about worldwide events sitting at home. Due to internet, every information is available at our fingertips. It has become possible to get advance alert about natural calamities and take proper precautions. During war, it is possible to get information about the actions of the enemy through aerial surveillance using satellites. It is also possible to explore the fossil reserves and minerals in the earth. Thus, there are unlimited applications of space missions. Today, space technology is an inevitable part for development of a nation. Artificial satellite. A natural satellite is an astronomical object orbiting the Earth or any other planet. The Moon is the only natural satellite of the Earth. Some other planets in the solar system have more than one natural satellites. If a man-made object revolves around the Earth or any other planet in a fixed orbit, it is called an artificial satellite. The first artificial satellite Sputnik was sent to space by Soviet Union in 1957. Today more than 1,000 satellites are orbiting the Earth. The satellites work on solar energy. So solar photovoltaic panels are attached on both sides of these satellites like wings. Instruments are installed in the satellites to receive and transmit signals from and to the Earth. The satellites have various other types of instruments depending on their functions. Signals transmitted from the Earth to the satellite and from the satellite to a mobile tower and mobile phones are shown in the picture. These satellites are sent into the space to perform various functions. The types and functions of satellites. The different satellites in India are INSAT, that is Indian National Satellite; GSAT, Geosynchronous Satellite; IRNSS, that is Indian Regional Navigation Satellite System; IRS, Indian Remote Sensing Satellite. Launch Vehicles GSLV, Geosynchronous Satellite Launch Vehicle. PSLV, Polar Satellite Launch Vehicle. Depending on their functions, satellites are classified into following categories. Weather satellite. The function of weather satellite is to study and predict the weather. The satellites used for this purpose are INSAT and GSAT, and their launcher is GSLV. Communication satellite. To establish communication between different locations in the world through use of specific waves. The satellites used for this are INSAT and GSAT, and their launcher is GSLV. Broadcast satellite. The function is to telecast television programs. The satellites are INSAT and GSAT, and their launcher is GSLV. Navigational satellite. To fix the location of any place on the Earth's surface in terms of its very precise latitude and longitude. The satellite used is IRNSS, and its launcher is PSLV. Military satellite. To collect information for security aspects. An Earth observation satellite to study forests, deserts, oceans, polar ice on the Earth's surface, exploration and management of natural resources, observation and guidance in case of natural calamities like flood and earthquake. The satellite used is IRS, and its launcher is PSLV. Orbits of artificial satellites. All artificial satellites do not revolve in similar orbits around the Earth. The functions of the satellite decide the height of the satellite's orbit from the Earth's surface, the nature of the orbit, whether it is circular or elliptical, and whether the orbit shall be parallel to the equator or making some angle with it. To put the satellite in its proper orbit at specific height above the Earth's surface, the satellite is taken to that height using a satellite launcher. Then the satellite is given a specific velocity known as the critical velocity, denoted by Vc, in a tangential direction to the orbit. The satellite then starts revolving around the Earth. The formula for the velocity Vc can be derived as follows. If a satellite of mass m is revolving around the Earth in an orbit of height h with a speed Vc, then the centripetal force mvc squared upon r will act on it. Here r is the orbital radius of the satellite from the Earth. The centripetal force is equal to the gravitational force between the Earth and the satellite. So centripetal force mvc squared upon r plus h is equal to the gravitational force gmm upon r plus h whole square, where g is the gravitational constant, m is the mass of the Earth, r is radius of the Earth, h is height of the satellite above the Earth's surface, and r plus h is the radius of the orbit of the satellite. So on solving, we have Vc square is equal to Gm upon r plus h. Okay, small m will get cancelled, r plus h and r plus h square. So 1 r plus h will get cancelled. So we have Vc square is equal to Gm upon r plus h. So taking square root, we have Vc is equal to square root of Gm upon r plus h. From this formula, it can be seen that the critical velocity does not depend on the mass of the satellite. As the height of the satellite's orbit from the Earth's surface increases, the critical velocity decreases. Depending on the height of the satellite's orbit above the Earth's surface, the satellite orbits are classified as: first, high Earth orbits. If the height of the satellite's orbit above the Earth's surface is greater than or equal to 35,780 kilometers, The orbit is called high Earth orbit. A satellite in an orbit 35,780 kilometers above the Earth's surface will take around 24 hours to complete one revolution. The Earth also takes almost 24 hours for one revolution. If the satellite is revolving in an orbit parallel to the equator, the time of revolution for the Earth around itself and that for the satellite to revolve around the Earth being the same, the satellite will appear to be stationary with respect to the Earth. For a passenger in one vehicle, another vehicle moving parallel to him with equal velocity appears to be stationary. This is what happens here also. These satellites are therefore called geosynchronous satellites. Since these satellites are stationary with reference to the Earth, they can observe a specific portion of the Earth continuously. Therefore, they are used in applications like meteorology and for carrying signals for telephone, television, radio, etc. Medium Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 2000 kilometers and 35,780 kilometers, the orbits are called medium Earth orbits. The geostationary satellites orbit above the equator. These are therefore not useful in the study of polar regions. For this purpose, elliptical medium Earth orbits passing over the polar region are used. These orbits are called polar orbits. In these orbits, the satellites complete one revolution in 2 to 24 hours. Some of these satellites revolve in circular orbits at a height of around 20,200 kilometers above the Earth's surface. Global positioning satellites revolve in such orbits. Low Earth orbits. If the height of the satellite orbit above the Earth's surface is in between 180 kilometers and 2000 kilometers, the orbits are called low Earth orbits. The satellites used for scientific experiments and atmospheric studies revolve in low Earth orbits. Depending on the height of their orbits, they complete one revolution in around 90 minutes. International Space Station and Hubble telescope also revolve in low Earth orbits. Suppose the orbit of a satellite is exactly 35,780 kilometers above the Earth's surface. How much time will the satellite take to complete one revolution around the Earth? Okay, so here we are given that the height of a satellite above the Earth's surface is 35,780 kilometers. The velocity of the satellite is given as 3.08 kilometer per second and radius of the Earth is 6,400 kilometers. So suppose the satellite takes t seconds to complete one revolution around the Earth. The distance travelled during this one revolution is equal to the circumference of the circular orbit. If r is the radius of the orbit, the satellite will travel a distance of 2 pi r during one revolution. That is, it will complete one circumference in one revolution. Thus, the time required for one complete revolution can be obtained as v is equal to distance upon time. So, distance is equal to the circumference. So, it is equal to circumference upon time. Circumference is 2 pi r. So, it is 2 pi r upon t. Okay. So, t is equal to 2 pi r upon v, that is equal to 2 pi r plus h upon v. So, substituting the values, we have 2 into pi is 3.14 into r is 6,400 plus the height of the orbit is 35,780 upon the velocity is given as 3.08. So, on solving we get 86,003.38 seconds. that is equal to 23.89 hours, that is approximately equal to 23 hours 54 minutes. Here, since the velocity is taken in the unit of kilometer per second, the radius is also taken in the unit of kilometers. Okay, so we'll stop here and we'll continue with this chapter in the next video.